I am so proud to be here kicking off 4C. My name is Jason Cahill. I am the tech director for Minecraft. I work in the Seattle area, and I've been working on Minecraft since the acquisition of Mojang into Microsoft, which has been about 4 years. I hope this talk is useful to you guys. I tried to pick some examples of how we have made one version of Minecraft and how we have opened Minecraft to an officially supported framework for modding. And I think these techniques are genuinely interesting and important to anyone building games, and so I hope that they help you and are interesting. I'm going to give you just a couple of minutes of introduction to Minecraft. I'm sure many of you have played the game Minecraft before, so you're familiar with it. But these are our design principles about what Minecraft is. It is a game about exploration, adventure, creativity. We don't force a player to play the game in any particular way. Most players come to the game and they make it what they want it to be. They bring their own fun to the game. We continue to add features at an incredible pace, and players continue to respond to it in a tremendous way. Our visual target is kind of fun. We're ugly cute. We're actually a retro pixel art, low fidelity looking game. That's intentional. We work very hard to make it in that vein. And we pride ourselves with the idea that we're also a bit ridiculous in terms of how our game works. So what is it exactly? It's a game about placing and breaking blocks, but it is, and it's been an incredible pleasure to work on this franchise, one game that truly transcends the whole industry. We are one of the most popular games, and we've continued to build our usage, and I'll show you the numbers in a moment, but we've continued to build our usage to really an incredible level as we brought that into Microsoft and we expanded ourselves onto a large number of platforms. The content that players play, we ship a vanilla game. That game is the sort of role-playing game experience in survival mode. We also have a creative mode where people just go in and build things like digital Legos. But the content that sticks for people, that lasts the longest, is the content made by our players and distributed by our players. And in the last year, we've opened up the main version of Minecraft to sell content from our player base back to players. And they make profit off of that. We are simply a store that exposes approved content to our player base. So Minecraft is available on everything, 20 platforms. From an engineering perspective, a fair amount of work. We spent the first 3 years since the acquisition getting to this point. We are on every console, every desktop computer, every mobile, and every VR platform. We ship simultaneously. We ship about every 6 weeks, and so all platforms get an update every 6 weeks. The lead times for some of those certification processes are such that we put our next build insert the day the last one comes out. So we are in a continuous pipeline of releasing Minecraft. We've had a total of 50 updates in the last year, and so until we added some console platforms where that slowed down a little bit, we were able to actually ship once a week. Now we are able to ship some platforms a little bit slower, but in general we try to ship on a continuous pass. New features every 6 weeks, bug fixes as needed. Now Minecraft is kind of an older game at this point. It's about 9.5 years old. You might think, well, it's had its heyday. No, it hasn't. These numbers were just announced last week at Minecon, where we have hit a new record of 92 million active users in a month, and we've now sold 156 million copies to date. When you look at that usage versus number of sold copies, it means that 50% of our players have played within the last month. So Minecraft is just an incredible game. Players continue to play it and love it ferociously. So let's talk about where our shared journey with Mojang began. We acquired them almost exactly 4 years ago. They had specific goals that they wanted to achieve through this acquisition with us. Things that they didn't have the expertise or the ability to do that they thought that a company like Microsoft could really help with. One of those was to make one version of the game. and we'll talk about that a bit more. 4 years ago, when we bought them, the heart and soul of the game was the Java edition. At the time we acquired Mojang, we had 3 different code bases across the top. We had the Minecraft that everyone knew and loved, which was the Java version. We had this up-and-coming Pocket Edition, which was still so new at that point. It ran on iOS and Android. Its survival game didn't yet have health and hunger and basic capabilities that you would expect out of a survival game. And then we had console editions that were built by another company, 4J Studios, in Scotland. And Mojang's first goal was to say, let's bring all of these together. We want one version of Minecraft. We want it to play everywhere. We want everyone to be able to play with each other regardless of device. And that led to a real technical dilemma, because all the features that people knew and loved about Minecraft only existed in one code base, and that was the Java version. Pocket was our fastest growing version, and it was built for super low-end phones, these very low-end Android devices. And we had to look at, well, what should we do? Should we try and figure out how to port our Java code to all the different devices? There were some challenges there. Some platforms don't let you, particularly at that time, run code that is interpreted. And at that point, 4 years ago, we were still missing ahead-of-time compilers for things like Java. So it was impossible for us to just take the Java code base and ship it on a platform like iOS. So what we did instead was we staffed up a large team, about 100 developers in the Seattle area, and we ported every single feature out of the Java version into what the time was called Pocket Edition. And we just completed last year the consolidation of all features from all of these platforms together into the game that is now just simply known as Minecraft. And we've renamed the version that historically has been the Java Edition as just that, the Java Edition. This led to a bunch of challenges, not the least of which is, what do you do with mods? In addition to the fact that the mind share of the game was in the Java edition, one of the things that the sort of most voracious players of the Java edition love about the game are these beautiful mods, like Harvestcraft, which is the ultimate farming simulator inside of Minecraft. Another example here is Railcraft. People go crazy with building trains and transportation systems and machines and factories. And the thing to remember about mods is that we didn't design them. Nobody at Mojang set out on a path of enabling mods. It happened. It happened because Java is inherently decompilable. It's shipped as an intermediate language. It doesn't compile until it gets to your machine, which means it's really easy to reverse engineer it, take it apart, write your own code into it, and now you have your own new executable that you can distribute to people. Over the years, the community has made that a bit more easy for people that want to install mods. They can go get packs like Forge to make mod installing easy. But neither Mojang nor Microsoft has ever endorsed mods. And the reason is you're installing somebody's full trust code onto your computer. And when you're running a mod, you could also be Bitcoin mining. You could also be keylogging. You could do any of the things that you could do with full trust code. And so we said, this is amazing. We were inspired a ton by some of these examples. This is one of my personal favorites. Ragecraft is a 40-hour RPG that you can just drop in and play inside of Minecraft. It's a complete RPG experience with 16 different missions. It's incredibly hard. They've created a whole slew of new creatures. And long before Battle Royale, a bunch of our server partners went out and made games like the Hunger Games, which had to be rebranded survival games because of trademark, but effectively that. So we had this real problem of, we have this new code base, it runs everywhere. It is a C++ code base. We want it to be extensible for examples like I've shown you here. How do you do it? Well, I want to talk about how we supercharge 2 scenarios inside of our C++ code base. Hopefully these things are examples that you guys can just pick up and take for your own games. They've helped us in ways that we didn't really expect when we built them. The first one, I'm going to take a quick detour, is the first new edition of Minecraft that we built post-acquisition, and this is the Minecraft Education Edition. It is the full game of Minecraft, but adapted to be sold to schools. And one of the scenarios we had to sell it to schools was teachers don't want to necessarily play the game, but they want to control what the kids are seeing and what the kids are interacting with, so it doesn't just become a melee or a slaying of kids getting swords and just killing each other during school hours. So we wanted to build an app, classroom mode, that let teachers see all the players in a multiplayer session, see all the chats and whispers that are happening, so you can make sure that they're not trying to team up on the teacher or, bully each other. You can pick up the kids and move them to safe locations. You can give them things. You can pause the game for instruction. Classroom mode has been, the Education Edition has now been used for 35 million play sessions inside of schools. So this has really taken off. And it's contributed to 90 million plays of hours of code experiences that we've built. So getting people to learn how to code inside of Minecraft. But we didn't want to build this in Minecraft. We wanted it to look like Minecraft, but we didn't want to build it inside of the game because we knew that this would be running on a teacher's laptop. The teacher's laptop may not run Minecraft. We had another scenario, learning to code. So here we wanted to have an experience that worked with code.org. It worked with MakeCode and Tinker. We wanted the full web experiences of coding with block-like languages in a way that could work against Minecraft. And to do that means, well, we had to build it as a separate app again. Well, how do you do that? Like most games don't just open up a port and be like, okay, have at it. You can do whatever you want. You can automate Minecraft. We also had the goal that this approach would work with Minecraft running on any of those platforms. I should be able to automate and control Minecraft running on a Nintendo Switch or an iOS device, regardless of where I happen to be doing my coding. So the first big insight that we had was we already had what we call as a slash command system. There's a way in the game for you to just pop up the text editor and run a command. At this point, most of our commands were simple things like fill a chunk of the world with rock or dirt, teleport me from point A to point B. We had a lot of banning and chatting and filtering commands, but nothing really to do sort of deep command and control. But we said, this might be an avenue. And so what we decided to build was to make Minecraft a WebSocket client. WebSockets because it's the easiest thing from a port perspective. Most things have port 80 open. So we have the opportunity for Minecraft to connect to any running WebSocket server. And once you connect, you can completely automate Minecraft. You can build any application you want that can run those commands. Being able to run commands is great. Now this additional app that's running either on the same computer or somewhere else can not just send commands, but we realized we need a way for that app to be able to listen. We had a telemetry stream. We had a way of sending what people were doing in the game up to our own services. So we decided to build a publish and subscribe mechanism as well. So you can subscribe from your little app that's running to Minecraft to say, I want to know every time a player moves. I want to know every time a player places a block. I want to know every time someone kills someone. And all that event stream just goes right over the socket. And so you can build totally custom tailored apps. At this point, and for about 2 years, 100% of our black box automation ran using this technique. It's basically just a remote procedure call mechanism. But by using WebSockets, it was super easy to deploy to data centers. It was just simple ports. We didn't have to do any special VM configuration. It was just a standard web app that happened to speak the WebSocket protocol. One key learning here, we actually started with the reverse. We started with Minecraft itself being the WebSocket server, and then you could build a little app that would connect to Minecraft. That turned out to be a terrible idea. This is actually the right approach. The reason for this approach is it's much harder to get your game to open ports or even to open port 80 on some devices than it is to connect outbound. And so having Minecraft be the client that connects outbound to something else ended up being exactly the right way to do it. So to give you a really simple example of something powerful that we've done, so this is our Learn to Code editor. This is one of the specific experiences called Make Code. Just like Scratch or just like Snap to the popular block-based coding experience, this is a block-based coding experience. You have standard commands for doing things like repeat forever, and in this case, we're going to fill some blocks. We use this as a tutorial to teach kids how to run code and run code against Minecraft. This particular example is basically saying, I want to fill with air 5 blocks by 5 blocks around me. And when we click go, let's see what happens here. This builds a little example that we call Super Digger. And so just the player running is triggering that on-player moved event, which runs forever. And it's very easy to get to a place where you just start digging through the whole world. And it's basically kids' first experience with programming, and it's fun. It's contextual, it's in the game. And with a couple of blocks, they can see themselves do something in a game that they love, which is even more fun than building these little web-based examples of Learn to Code projects. And then we had some challenges. So once you give people commands like the fill command, this is what everyone wants to do. They want you to run a fill that fills some massive area of the game. And to this point, our slash commands were kind of designed as something that you did interactively. When you pressed enter, you sort of expected that, it's going to take a second or two, it's fine. This is now an extensibility port that's open to anyone to be able to plug in and fire commands at it. And the challenge here is that some of these commands can take seconds to accomplish. So you basically kill the main thread when you're running this command, which means you take the server offline, which means you kick all the kids out, and now you've got angry teachers. So what do we have to do? We built a background job scheduling service where we moved to the pattern of promises. When I connect to when I send a command, like I issue a fill command that's going to affect hundreds of thousands of voxels in the world, what we return you is instantaneously a promise that we will tell you when it is done. We'll tell you that it is done and successful or that we failed for some reason, but we return immediately. And then inside of our scheduler, we break down that task as best as we can, sometimes we can't, into little bite-sized tasks. If we're doing something like a fill, it's really easy to break down into little chunks so that we can run it and schedule that we want to spend not more than 1 millisecond per frame doing these commands. So it scales super well, gets it off the main thread, and it gives me a way as an app to be able to listen for completion, success, and fail. So that was scenario number 1. Again, this was really eye-opening for us, and in particular, we've evolved how we've done black box automated testing, but this notion of we can control the app as a player would from completely outside was more powerful than we initially expected. We have some AI research that's happening at Microsoft, and they use this mechanism as well to act like a player, to consume the video stream and try and make bots that can play this game. And when they do that, this is the mechanism that they use as well, so that they're not, they have the exact same limitations that a human player does in terms of sending commands and moving through the world. So, second scenario I want to talk to you about is how we turn our player base into creators. And this is getting closer to that set of mods that I showed you in the beginning, the things like Harvestcraft, where I make super farming games, or Railcraft, where I make train transport and machine scenarios possible. So many Minecraft players go through a life cycle that looks like this. They start by playing the game. Just a regular old game. They find wolves and they tame them, and they work with our procedurally generated world, and they play for hundreds of hours just enjoying the game as it was designed. And then they get to a point where they're like, I can do better. I want to start making my own fancy worlds. And they start to go off the deep end of building things like farms. This is still pretty simple, but this is the player that has gotten the bug of like, I want to build more. I want to try making something. And some of those go all the way to the extreme of building incredible things like this. This is a 2-person build. This is a partner of ours called Blockworks. They make a lot of our They make a bunch of our licensed first-party content, and they're incredibly talented world sculptors. We've since opened our marketplace to other creators, and we now have something like 750 pieces of content from creators that are sort of on par with this. One of the things we wanted to be able to do was not just make beautiful worlds, but actually make new gameplay experiences. So I can show you a quick clip. Let's see if it starts. So this is the kind of content that creators are making right now. Big, beautiful builds, incredible new creatures like those robots. And we've built this store that allows us to actually package and sell these creations. So a whole range of new looks, new worlds, and new all-up capabilities with different player expression and different looking creatures. Now the challenge here is we want this to run against that version of Minecraft that runs everywhere. And to do that means we have to be able to open these extensions without code. Because if you look at the policies of some of our platforms, particularly Sony, particularly Apple, they don't like the idea that you can run arbitrary code on their console or on their device. We've been working with these partners for a very long time to figure out exactly where the finesse is in those rules and what we can and what we can't do. But we took a different approach at first. What we decided to do was make all of our data types for creatures, for blocks, and for items data-driven. And this gets back to that technical challenge, the dilemma I mentioned right off the bat. We decided to staff up a team to go port every feature out of Java into this game. Now, when you port code, you're generally going for speed of porting and not necessarily code quality. The Java version, which is almost 10 years old, has an incredibly deep class hierarchy. So if we look at the wolf is a tameable animal, which is an animal, which is an ageable mob, which is a pathfinding mob, which is a mob, which is an entity. If you're all looking at this going like, ECS, why aren't you using ECS? 10 years ago, ECS didn't exist, and Notch was a huge fan of object hierarchy, class inheritance, and so it's all over the place. Even the creeper, something as simple and iconic as the creeper, is 5 layers deep of classes. How do you expose all the data for a creature like this that is composed of all these classes, well, inherited of all these classes, not actually composed? The answer is that we built our own abstraction for creators. We built JSON formats that allowed us to describe all the behaviors, and the behaviors run on our servers. So even if I'm playing single player, I'm running a Minecraft server on my device. We separated the server behavior and the server data driving from the client behavior and the client look. So our resources include things like, what is the textures that I use? What is the animation controller? What is the sounds that it plays when it does things? And we were careful about thinking about what abstraction layer do we want to build to map our data to these creatures in a way that will work forever, so that even though we started with a class hierarchy that looks like that, we don't want to live with this class hierarchy forever. We're going to want to be able to clean up our code and move to something that is more ECS-based, but we want to be able to make extensions that will last forever. So this was actually the first place that we went through and said, let's think about how we want to shape our objects. And we opened up these formats. We've published blog articles and videos teaching our players, here's how you replace entities or blocks or items in the game with new versions of those. So to pull this off, and I'll show you some more examples in a minute of what we built, we had to do a bunch of work. So first we had to go and architect a JSON format that described all the various pieces that made up our in-game entities. And in some ways, it looks like an ECS pattern to our players and creators. But the critical point is it is completely abstracted from how the code consumes it underneath. There is no means of somebody going in and poking the direct data structures that we use inside the game from these formats. And that's very different than how Java Java modding works, where you literally just go in and you're like, I don't like this data structure. I'm just going to add some more fields to the data structure, and then I'm going to ship my version of Minecraft that has changes to the data structure. And then your mod doesn't work on the next version or even the next point release because we fixed some bug that changed the order of the data structure, and now your mod doesn't work. We separated the description of behaviors from the description of all the client-side models and textures and entities. We made it as simple as possible for players to only tell us what they wanted to change. So like cascading style sheets from the web world, you only need to tell us the things you want to override. You don't need to go and specify a full copy of here's what a wolf looks like if all you want to do is make a wolf twice as badass. We defined custom model and animation formats. So we didn't go use an FBX. We didn't go use some standard like Maya format for models. Partially because 8-year-olds don't have access to tools like that. And a lot of our neatest content is made by creators that have never actually sat down with anything more sophisticated than, say, Blender. And our community is passionate about building tools to support their content creation. And so what we did was we went and documented, here's the format if you want to make a model, and Minecraft will load it, and it will work with it, and work with it forever. And it's not tied to any specific content creation tool. So we came out with 1 through 4. We shipped some of the content that I showed you from those videos. And then we kind of ran into a problem with our community, which is everyone got excited. Everyone ran out there and they started building their own custom creations. And they noticed that their stuff didn't load. You had a lot of inexperienced people that would go work in JSON and they would remove a comma somewhere in there and they'd be like, it doesn't work. Add-ins don't work. So we had to go and we had a C++ JSON parser, and the parser was just an open source parser, but it assumed you were always basically going to give it correct input. Oops. Most of the time we get incorrect input from our users. So we had to go and throw that away and go build our own JSON parser that could handle things like comments, which are not really part of the standard, could detect parse errors. We had to go build an integrated error console so that when you load a piece of content that you've made and there's something wrong with it, there is a means of seeing, oh, line 35 of this file is missing a comma. And it's not meant for players that are trying to consume these things. It's meant for the creators that are sitting there and using Minecraft and Notepad together and hacking away and saying, I want to make something really cool. They need basically a development tool inside of the game itself to show them what's going wrong. We also built a whole bunch of logging techniques that go above and beyond this. So if you really are stuck, if something's really wrong, if you've made a texture that is too high resolution and it's killing your Android device, you can get logging that will tell you exactly what went wrong. So as a creator, you can sit there and go through a REPL of trying things until it works. The last 2 were superpowers for getting stuff virally into the game. The first one is making it possible to just be able to click on an MC World or an MC Pack from a URL in your web browser on any device you have a web browser on. If I'm running on an iOS device and I'm in Safari and I click a MC World file, we built an app activation for that so we can just launch it straight in Minecraft. So it's incredibly easy to go get free content off the web. If I'm a casual player, there are well-known sites like MCPEDL where I can go and just find all the latest add-ons and worlds and adventures for free, click on them, load them into the game and start playing. And most recently, at this Minecon we held last week, we announced the ability to add entirely new entities and items. To this point, until this last step, you'd only be able to replace things that already existed in the game. I could take a wolf and make it into a better wolf, or I can make a creeper not blow up anymore. But I couldn't add something totally net new. And that was the next thing that we really wanted to get done, was make a sandbox where anyone can create any kind of new creature or experience in a totally data-driven way just by editing JSON files and distributing it as an MC pack that you can link off the internet, and it just runs in the game. So to give you an example, here are some spider zombies. So we took the zombie and we added the spider climbing component to it. And so with literally one line of change to our JSON, the creatures just behave differently now. Now they're wall climbers. Now, if I wasn't in creative mode, they would climb the wall and come kick my ass. And so incredibly fun, especially for somebody that's new at creating something like this, with just a couple of, some learning and a couple of edits to scripts, you can totally change the basic behavior of a creature that's in the game. What we've just enabled, though, is something that goes a bit further. So if you've played the game at all, you know that we have chickens. Put down a chicken. Well, what if we want to add ducks? Oh, there's a duck. Chickens are bred by feeding them seeds, but it makes more sense for a duck to be bred by using bread. So put down another duck, feed them some bread, and they'll make a little duck. There it is. It's just so easy. A bunch of things happened here that are super cool. The first one is we defined an entirely new entity by making duck.json and just putting it into a world that I can distribute in any means possible. I have the way of adding this new creature. I can set its spawn rules, like the biomes that it spawns in, the behaviors and capabilities that it has. I can define that baby ducks don't look like adult ducks. I can change any of the rules around how does a baby duck grow up into an adult duck? What do they eat? How do they attack? Do they respond, etc.? Taking this further, we built an example of how you can create new enemies in the game. And this is a new boss-like that we've made. We took two of the models for creatures that already existed in the game. This is what is it? It's called the Defiler and a spider, and we put them together. So this creature not only is pretty hard to kill itself, but it spawns these horrible little poison spiders. So I'm going to get completely overrun by the spiders because I'm not attacking the main boss. So what's really cool about that is, again, from a content creation perspective, players can now make entirely new interactions, entirely new monsters that can do anything the game can do. It can spawn these little bad guys. They can come after me. I didn't have to write any code. I don't need access to Minecraft source code to do this. And so I can start turning this sandbox into whatever it is I want it to be. Opening up your data formats like this not only makes it possible for people to make mistakes in the data formats, it makes it possible for us to mess up as well. And so I always like to remind people how much you do have to take testing seriously. In the vanilla game of Minecraft, if you attack a wolf and there's a pack around, then they will come and attack you as well. So here we've got a wolf. Go ahead and punch it. This one comes along. And there was a bug where you were able to make it sit, and now it's just doing this sort of infinite butt scooting. And so this was, it's hilarious, but it's also just sort of evidence that you have to be very careful as you open up your data formats to go back and make sure you have a comprehensive set of unit tests to prove that your existing behaviors all still work. So we can add new things. We can add new monsters. We can go and test these things. We have to also forget the whole point of this is to make it fun for creators. And so here's a sort of comprehensive example of add-ins in process. So we've added a new chicken ignited in our JSON. Don't know what that does. Put some chickens out there. All right, what happens when fire comes in contact with a chicken? Well, we can describe that now too. So that's cool. Again, we're just editing data. So super fun, just a couple lines of code, and I was able to make chickens explode when they get set on fire. They recursively blow up themselves, and as you saw, the game actually chunked a little bit when it got too much at some point, but like you could turn a beautiful world into something that was just utterly devastating. Everything I've shown you to this point was around, first, the ability to replace our creatures in the game through data driving, and then second, the ability to add new creatures like ducks or that defiler I showed you. But you still can't define any new behaviors that don't already exist in the game. So I can make a duck that kind of acts like a chicken and overrides some of its behaviors. But the next step is, what if I want to make these things do completely new behaviors? What do you do? And so we just announced that we are making a tech preview of scripting available. So now we'll take it to the sort of ultimate extent, which is, you want to build mods inside of Minecraft? Well, not only can you do it on every single platform, but we have one language that is supported for doing this. You might scratch your head a little bit and go, JavaScript, really? Well, the advantage of JavaScript is it is a language that truly runs everywhere. We have a JavaScript interpreter available on every platform, and even some of the more challenging platforms like Apple's platforms allow you to, by the book, you can ship your JavaScript files with your game, and that is perfectly in policy. And you can also include scripts with content, so long as it doesn't fundamentally change the cert status of your game. If somebody's able to exploit JavaScript to do something like make a Super Mario emulator, they might have an issue with that. So as we will ship, we will make sure that our marketplace is always selling content that we know what the scripts are and what capabilities they add. And then the internet does what the internet does. If people are distributing mods out there and they do stuff with JavaScript that is beyond the confines, well, that is content created after, and still sort of in a gray area. We're working with some platforms to figure out exactly what we can and we can't do. The other piece that we are looking at in terms of making this capability more powerful is separating our game and having a dedicated server executable that we ship. So if you want to run your own Minecraft server, well, that doesn't run on the iPad, or that doesn't run on an iPhone, and now I can put my scripts inside the server and run them. And we're not running any scripts on the client. And so I can make as rich and extended a world as I want, and we aren't violating any policy rules. One of the things that's interesting about policy rules is it really depends what country you're selling to. All throughout Asia, it is extremely common to have Python and JavaScript language parsers just built into the game. The first thing your game does when you connect is download all the latest scripts and update the game. You don't have to go through App Store cert. And that's accepted in that region of the world. In the United States and most of the West, that is not an acceptable process. If you have an app that's getting away with it, congratulations. You are not on the scrutiny list of like an Apple or a Google yet. If you get to a level of success, they will come and look at you, and they will look at you deeply, and they will say, you seem to be breaking this rule. And they will interpret the rules for you, and they will make you change your app. So be careful about some of their certification processes around things like scripting. We've been very slow in moving this way because of the fact that we are really pushing the limits of what is possible in this space. And so with that, I'd love to turn it over and see if there's any questions from you guys. Yeah, so great question. So on iOS, we are specifically using JavaScript Core, the JavaScript engine that they ship and certify. On other platforms, we are using Microsoft's own Chakra Core, which is an open source JavaScript engine. We have better JIT control, like the ability to just-in-time compile our own JavaScript for platforms that aren't as concerned about things like JITting your code. What it means is that we have to build an interface between the engine and the JavaScript library, and so we have 2 libraries that we host, JavaScript Core and Chakra Core. But those are super small C APIs, and basically they port directly between the 2 JavaScript libraries into our engine. So that part actually wasn't that hard to pull off. The harder part about getting JavaScript bindings right is going into the game engine and exposing everything in a JavaScript object model. We are also working on updates to our UI system as well that take JavaScript bindings, so that in the future people will be able to build basically JavaScript editable UI as well. Because the next thing you get is after you have creatures and you have items and blocks, you want to start having interactions. You want to walk up to some new trader and be able to ask questions and trade with them and have those kinds of sort of deeper interactions.
Hey, so the question, in the beginning you said that your production cycle is 6 weeks.
Mm-hmm.
So basically you release the version today, and it means that you'll be starting to work on the version that's not the next one, but the next one. Does it happen that when you release a version, you see that something is wrong there, and you have to fix it in the next version, but not the next version? What do you do then?
That's a great question. So the 2 cases we care about the most that cause those problems are some sort of a security vulnerability, such as there's a very early crash in the game that would impact a large number of users, or sign-in doesn't work, or our store and monetization stopped working. Again, since we don't use any scripting for that stuff, we can't actually patch and fix our game on the spot. So in the event that we ship a mistake, and we had a pretty bad marketplace mistake on iOS for about a 1-week period. We get on the phone with Apple and we call them and we talk to them about, hey, we have a fix, we need to get this out there as quickly as possible. And there are exception processes to certification. The typical cost of calling an Audible like that and saying, hey, we need this out as fast as possible, is that they're going to do a very deep review on the next build that you submit to make sure that not only did you fix that, but any other grievances they might have will come out at that time, and you will have to maybe do some extra work to tighten up support on their platform. So those are definitely worst case scenarios for us. One of the challenges with supporting the number of platforms we do is that it is very likely that little mistakes occur on one platform or another from time to time, and you have to deal with it. As a general rule of thumb, we are about a month to 6 weeks ahead of what is about to come out. So literally, as a build comes out, we push the button, because many of the cert processes can only tolerate one build at a time. So they're looking at a build, it is holding up the cycle. If you change the build on them, then they, oh, well, we're just going to stop cert on that then. So you have to wait for the build to come all the way out and through before you can put the next one in. So we are in the final days of testing the next build just as soon as the first one comes out. Unless, of course, we have some hot fix where we have to stop everything, go patch that, and then ship ship immediately. There was a question back there?
Yeah, so you are opening Minecraft to JavaScript in general, which is great, but opens also a world of pain, especially for people developing the mods and potentially using them.
Yep.
So when you guys are working on Minecraft, you have obviously a lot of tools to debug, to check for errors, to test.
Yep.
Will you make anything for the modders to be able to debug the JavaScript, or maybe do some testing, or anything in that regard?
That's a great question, yes. So one of the nice things about JavaScript, and the reason we chose JavaScript over some other, we actually did a long set of experiments with other languages and runtimes before ultimately setting on JavaScript, is that there is a debug channel that is well documented for Chrome and Firefox and Edge and other browsers. So you can actually just take your web browser on the same PC you're running Minecraft on and connect to Minecraft from the debugger right inside the web browser and use the built-in JavaScript debugger right in there. Or you can use a tool like Visual Studio Code that uses that same channel to connect directly to Minecraft and debug your scripts. So if I'm a creator, it can be as easy as just use my web browser because development tools scare me, all the way to I'm powerful developer and I'm actually trying to make really high quality content that ultimately I want to sell in the store, at which point I can use Visual Studio Code or even full Visual Studio to sit and debug Minecraft in that state. So it's super cool. Was there one more? Yep.
Hello, thank you very much for a great presentation.
Thank you.
Wanted to ask, actually, I'm playing Minecraft for ages, and I've been using Techie the most as one of the modpacks. How many of the old timers are actually now, from the creators, are swapping to your new system, and how many of them are actually forcing you to still sort of maintain the old pipes of doing the mods?
So we continue to ship the Java version of Minecraft because there is a set of creators that love that coding flow. They love building Forge add-ons, bucket plugins, the whole set of works. And we're not interested in losing any of our players. And so the Java version is continued to be supported. When we shipped our major update in July, the update Aquatic, which is the first set of major features that we've had in the last couple of years, we shipped them identically at the same time in both. So we are doing co-development of gameplay features in both Java and Bedrock, which is our C++ version, so that we don't upset any of our players. If you want to be a creator for the Java version, that's cool. There's no marketplace for that. And so what we're seeing is that partners that want to be able to monetize their work are coming over towards the Bedrock side. One great story, when we shipped our store last year, we had one of our launch partners for content was a 4-person sort of hobby activity, and they had built this incredible mod to Minecraft that they had made $13 on. That was the entire amount of money. They'd put the mod behind a paywall of click-through ads. They'd put hundreds of hours into it. It was a 20-hour playthrough experience that was really amazing, and they made $13 on the whole thing. They had jobs at places like Best Buy, they just, like a large appliance store sort of thing. And they would come home and they would do this because of love, not because of making money, but that was their goal. Within the first month of launching their first piece of content, which was Destructibot, that little sample of the big red robots that were running around, they were able to all quit their jobs and start a little studio, and now they full-time make content for Minecraft. And so we are super proud of the fact that we've worked with a number of creators that have gone from, I do this as a hobby, to now this is my full-time job. And they're a new class of game developer. They are basically a game designer that makes gameplay experiences that run in our sandbox. And so it's amazing. Maybe one more? No?
We got time for one more question. Anybody?
So with opening the world to external content producers, how does that interact with your ratings and things like that, where you get a rating for the title and you're letting people click through and just load arbitrary content? And with internets, how does that work?
That is a great question. So the store that I showed you that's in the game, all that content that we ship in there has to be E10 content. And to get into our store today, you work with us as a partner. So you reach out to us, you give us a pitch, we approve the pitch, at which point you'll submit a draft of here's what my content looks like. It's almost like a mini greenlighting process for a game, except it's a level or a texture pack or a little adventure. But we take child safety super seriously, and we want everything that's in our store to be the same rating as us. And so we have to make sure it's brand appropriate, copyright appropriate, trademark appropriate, and actually works and is fun. And so we have our own cert process for that, at which point we release it. If a creator wants to make anything they want and ship it on the internet, that's fine, but then the rating is, you've gone outside of the bounds of what you can get directly from the game. We did make it easy for you to go use your web browser, click on a piece of content, and start playing it in Minecraft, but that is outside of the standard ratings flow for our game, and so it doesn't count. Which is why you see a lot of these ratings that say online experiences vary.
All right, so all the stuff in your content store, does that actually have to go through cert as well as part of content for it? Will Apple look at it? Will Microsoft, Sony look at it? Or is they're like, you make sure you don't screw up?
The content that shows up in our store can show up on our cadence. It can show up independent of cert. The rules that we follow today is that no content that shows up in our store fundamentally changes the rating or the behavior of the game, and so it is acceptable on all platforms for us to push new content without a Nintendo or an Apple or a Google having to look at it. If we screwed up in a serious way, I'm sure that they would change those rules very quickly. So we're very careful about making sure the store only has safe content.
Very interesting. Thank you.
Yeah. All right. Well, with that, I want to thank you all very much for the time here. It's been a pleasure to chat with you. Enjoy your conference.